Can you imagine a world without other animals? No majestic elephants roaming, no playful dolphin leaping through the ocean, no graceful eagle soaring through the skies. It's a chilling thought, yet one that has loomed ever closer as wildlife trafficking continues to decimate populations across the globe. But regarding to this reality, there is a hope, the power of AI. Welcome to our presentation for the IMI Big Data and the AI competition. We are Group 70. This presentation will be covering Task 1, Supervised Learning, Task 2, Unsupervised Learning, and Task 3, Finding the IWT networks. So in Task 1, we managed to achieve the belonging goals, which includes constructing supervised learning model to identify high-risk clients, identify trend in wildlife trafficking using data supply, identifying recognized wildlife traffickers and connecting with pre-arranged clients. Our projects start with the data pre-processing to prepare the data set for in-depth analysis. We first merged other data on KYC dataset by joining the customer ID using pandas. After that, the initial analysis revealed a significant imbalance in our dataset class distribution. To address this, we sampled 5,500 records from both classes, ensure our final dataset is balanced and conducive to unbiased analysis. An illustrative example of processed data set is provided to highlight the data preparation outcome. To further refine our datasets for optimal model performance, we split into training, validation, and test subsets, following a to 1 ratio. Additionally, we encoded the categorical data and the standardized and numerical data to streamline further analysis and the model training processes. For the model training section of our project, we evaluate four supervised learning model, KNN, logistic regression, random forest, and NAN. Given that we have already addressed the datasets balance during the pre-processing, our comparison focuses on accuracy and F1 score on validation sets to determine the most effective model after hyperparameter training for each of the model. The result has shown that the random forest model outcome has outperformed the others, achieving a 93.54% accuracy on the validation set and the 91.45% accuracy on the test sets. In our analysis, we identified and examined the misclassified samples by comparing predicted and the actual outcome, revealing type 1 error associated with a higher transaction amount, suggesting larger transaction might lead to incorrect positive predictions. Conversely, type 2 errors has lower transaction amount and were more frequent among specific occupation like civil servant and real estate agent. This examination helps to pinpoint potential models improvement and highlights the importance of considering transaction volumes and occupational data in the predictive accuracy. As for text 2, so in general, we need to locate a key customers in the wildlife trafficking network first in order to track the whole network. Hence, we do text 2 in the 3 steps approach. In the first step, we decide what is our saturation for key customers. In second step, we identify the key customers of the network. And then finally, we identify the network as itself using the key customer. So how do we decide the saturation for key customers? We have 3 criteria. The first, the top 1% transaction amount are most suspicious. Second, someone who does business with too many different people is suspicious. Then lastly, if there's a certain customer has transaction with 2 or more high-risk group, then they're suspicious. So by doing this, we implemented our saturation using network X. So we imported the data from KYC and the other 3 data sets for analyze in a graph format. And the detail will be explained in the text 3. Creating a directed graph with the customer as nodes and all transaction as the edge using the network X, and filter out the key customers using the saturation discussed earlier. And the role of money move is the key in the transaction hit network of finding suspicious transactions. So when money move is defined as when found enter this row, it goes out at the same time. Therefore, we're focusing on the person who has a total account income amount is equal to a total amount of outgoing account. This kind of person might be a money move. And this saturation is also our main reference for saturation because it leads to money laundering and the other suspicious financial activities. So by doing task 3, we have finding suspicious entity and networks of wildlife trafficking. We take 2 approaches. The first one is visualization. The second one is the large language model. So we take 3 steps. There's 3 goals of using visualization to this task. First, find if there's n-layer connection between direct transactions. Second, present the cash flow and track the starter and the destination. Third, finding the core clients who has transaction with founded big criminal groups and the strengths to provide supervision. So as I mentioned in the text 2, this is the result of using network X. So in this graph, there is 3 colors of nodes. The red one is the direct the chosen node, and the green one is the node who has direct transaction with the red node. And the third one is the blue, which is the node that has no non-directed transaction with the node red. So, and I have to mention that for all these nodes, they have the same transaction amount, which means if red has sent $100 to greens, then the greens must send $100 to all the blues. By using this network representation, we be able to define who is suspicious client, as in this graph, one node has spread the same amount of transactions to like many customers, which is very suspicious. And by using this, we'll be able to define who is the money move, who is the bad actor in this transaction. And then finally, we'll be able to reveal the network of the like suspicious transactions, including wildlife, animal trafficking. The second solution is to use a large language model because you will be able to provide text pre-processing, entity recognition, task classification, semantic analysis, and the prompt engineering. This will automate the process of identify and supervise the transactions. And for this task, we have used the GPT API, and right now it's presenting the result of our attempt to use this large language model. First, we have fed all the well-known criminals who have revealed their names and have a specific description of what crime does he have done. And after feeding out our models, we'll be able to use sentences, English words to ask the model if a person by description is likely to be a wildlife trafficker or not. And for this photo, we have tried use a undergrad students an undergrad introduction to test the model if the model thinks he is a wildlife trafficker. And the second one for here, we use the actual description of a criminal who committed against to animal trafficking laws. Then the result shows that yes, based on the information provided, that this person has some relation with the wildlife animal trafficking. And this is the end of our presentation. Thank you very much.